Exploring Pytorch on Raspberry Pi. Hands-on tensor data manipulation for AI enthusiasts. Part 1 of multiple videos. Welcome to Inside Builder channel. Why we want to explore the Pytorch on Raspberry Pi? First, we have to internalize the structure of the Pytorch library. Before we start using the various methods and classes in the Pytorch library, if you start working on the basics of each of the classes and the methods and understand how the data output modifies, you can work with it in a faster and more efficient fashion. So that is the one of the important purposes. Second is that once we start implementing these methods in a smaller, more controlled data set, we can see how the Raspberry Pi responds with its temperature, with its memory usage, etc. So for that, we are going to understand these commands like VCgen command, which can give the memory of the CPU, GPU. Htop, we will be using the VCgen command measure underscore temperature flag, etc. So we'll be seeing these things in practice. Next is, what are the methods and classes of Pytorch? I have tried to provide a brief overview here. I have not covered all the classes in all the types that you see here, all the modules that is. So in data manipulation, I have covered those methods that we will be frequently using. In case of model layers, the same thing I have done. I have collected the classes that we will be frequently using, and then the same thing I have done in optimizers and loss criterions. However, as we go into each of the videos, each of this model layers, optimizers will have its own videos, and those videos will have more information. As of now, this is just a overview that I want to give to you guys. Next, what we are going to do is we are going to move to the command prompt. Let's go to the command prompt, and here I am already connected to the Torchit RPI, that is the Raspberry Pi that I am using. The host name of that Raspberry Pi is Torchit, so you can find it out using uname. So if I do an uname -a, you'll see that it provides the OS name, and after that the host name, and then the version, and when it was installed, and when it was created, what is the architecture, and a lot more stuff. Next, what we are going to do is we are directly going to jump into VCgen command and measure temp. Why we are measuring the temp and what temperature? At this moment, when we executed VCgen command space measure underscore temp, we got a temperature of 54.2 degrees Celsius. This is the CPU of the Raspberry Pi core temperature. This temperature, the Raspberry Pi that I'm using has passive cooling with the heatsink, and it is running at 54.2, and my room temperature is approximately 30 degrees, 28 to 30 degrees. So that is the current scenario of the Raspberry Pi. As we start processing, doing some activities, we need to keep an eye on this Raspberry Pi temperature, right? So for that, we will be using a command called as watch for every 5 seconds. So we'll be using the -n flag with 5, meaning every 5 seconds we will watch it. And what command we are going to watch? We are going to watch the VCgen command with the measure temp flag. So once we do this, every 5 seconds the VCgen measure underscore temp command will be executed, and this particular temperature value will keep on updating. So this one will happen in a separate window. So I will keep this window running. Now let us go to the another one, a tab in the same terminal. This is I am connecting to the Raspberry Pi via SSH from Windows 10 machine. The idea here is that from any machine, whether you are in Linux or Mac or Windows, even in your cell phone, so you can actually connect to Raspberry Pi through SSH, and you can start working on the commands that I'm using, because Raspberry Pi has got the Torch already installed. Next, what we are going to do is we have to understand the memory that is available. So for that, what you'll be doing is we'll be using something called as, let us take a look at the temperature. The temperature is 54.2. We will use the command called vcgen command, and we will use get underscore mem, and we will provide the flag as CPU. And once we do that, we will see that the CPU memory is actually 0. And if you do GPU, you will see it is 76 MB. So GPU is 76 MB. And let me run the CPU again. Just give me a second. Sorry about that. We have to use get mem arm. Once we use get mem arm, we will get the available memory of the RAM that is available for the CPU. Since this is an ARM architecture, the Raspberry Pi that I'm using is 3+B version. So I'm getting just 1 GB of RAM. And if I use the GPU, then you will see that I have a 76 MB of GPU. We have seen how to measure the temperature, and we are already watching the temperature. And second is we have seen how to get the memory that is available, and third is we have to see the memory that is getting used. Here we see that I have used the command called as htop. Htop is a more easier version of top command that is available in Linux. Here we can see the swap memory that is getting used, the actual random access memory that is getting used right now. Around 288 MB of RAM is already used by some application, which we will discuss in a couple of minutes. And these are the various cores and their respective usage percentages. Rest of these things you don't need to worry about at this moment. Our intention is to mainly look at the RAM that is getting used. So keep this also running. So let the temperature of the Raspberry Pi keep running, and let the RAM we can modify. We can view that from the htop. Also, if you guys are if you want to keep it in the same window, you can actually split the terminal window as horizontally, and you can keep it at the top. So that is also a good idea, but I am going to open a new terminal, and here I am going to do an SSH again to the RPI whose host name is torchit. So once I am inside that, I am going to zoom in a bit. Now what I am going to do is I am going to I have to right now start working on torch commands, right? So initially I have told you that I'll be discussing about these commands. I have shown you about that. You can actually visit this particular link, which I will be sharing in the description below. There it provides a lot more information on vcgen command and the various supporting flags. It also discusses about htop, free, and also various other Linux command that you can use with Raspberry Pi. So I suggest that you guys actually go to this particular link and learn more about Raspberry Pi, because we are going to use Raspberry Pi for AI modeling as well as inferencing. So this is going to be very, very important, especially to understand how the Raspberry Pi CPU, GPU, and the RAM works, and how to monitor it. That's one of the important points. Next, what we are going to do is we are going to start diving into the data manipulation part. Most of the videos, whichever you have seen till now, for data manipulation, the most sorted application is using a Jupyter notebook. However, I am going to use a regular Python script, but the difference is the Python script is going to be written in VScode. So the VScode, the draw.io application that I'm using for showing this presentation is running in Windows and Windows VScode application. What I'm going to do is I'm going to go to the Remote Explorer inside the VScode, and I'm going to just do a refresh on the various remotes and tunnels. Since the torchit RPI is in the same LAN of the Windows machine, once I do a refresh, the torchit username, torchit hostname RPI comes up. And once it comes up, all you need to do is click on this connect to in the new window. Once you do that, it will actually open a new window. It will open a new window like this. And here you can see that I am already connected, and you can run the vcgen command here also, and you can keep measuring the temperature here also. There is nothing stopping you. So we can see the temperature here too, and you can do the watching here also. The idea why I'm using VS Code is twofold. First thing is, as I told, I want to run the script which is going to be written in VS Code. And second thing is, the VS Code interface for working with RPA has been really streamlined. Not just RPA, with Linux is very much streamlined right now. Just by clicking the this particular option, just by clicking on this particular arrow or this particular option, the SSH interface starts. The SSH program by itself connects to the RPI SSH service, and it does all the work. In fact, in the background, inside the RPI, the VS Code server is downloaded, and then the VS Code server is started, and from there only we are getting this entire window. But this window right now I am using it in my Windows machine, so this is not in the Raspberry Pi. This is in my Windows machine, and I will get all the speed and the power of the Windows machine and still do everything inside the Raspberry Pi. So this is one of the cool thing that I wanted to share with you guys with respect to this Raspberry VS Code. Next thing is, what we are going to do next is we are going to start working on the basic methods of Pytorch. So let's first of all import torch, and we have to check the torch version. That's what I've done here. And once you have created the file, that is a Python script file, I'm using the name pytorch _ data manipulation.py. That is the script name that I'm using, and I have already typed in the import as well as the version checking line. So after that, all I need to do is I have to execute the pytorch data manipulation.py script, and I'm going to do that right now. So before I do that, I will go into the folder called as practice space, and from there I will execute the script. So once I execute, it is going to take a bit of time. That is because whenever the Python imports the torch, it's going to take a little bit of a time, and once it imports, it's faster, but till then it takes a bit of a time. So this is one of the challenges that we will face. So whenever I'll be executing the scripts, I will try to pause the video and start it again. Here we see the version 2.1.2 gets printed out. That is the torch version that we have got. Now we know that torch is working, and we know that the VS Code interface that we have created to the Raspberry Pi is also working. It was pretty straightforward, right? Not that difficult. In case, if in your case this interface doesn't work, you can always go back to the terminal and you can start doing the same thing here also. Nothing is stopping you, right? The same execution that I did it inside the VS Code, you can do it here also. And in order to edit the script inside the terminal, you can use Vim or Emacs. It's your choice, but at the end of the day, VS Code makes the life way more easier, because it provides lots of features like auto completion, various linters which helps you to avoid errors. It also helps you to remember. I mean, it actually gives the methods ahead of time, and also it provides the arguments in various methods that you're going to use. So that actually reinforces your learning at a very high speed. So those are the advantages of working with VS Code. That is one of the primary reason I shifted to showing the methods in VS Code and practicing it there. Let us now jump into the various methods that I want to discuss. So starting to work on Pytorch methods. Okay, so first method that we are going to see is once. So this is going to provide the matrix tensor of filled with ones, and it is going to provide the tensor with the shape that we are going to input here. So let us say a1, and we are going to say torch dot once. So you will see that it auto completes, and the moment I open the bracket, we can start updating the size. So I'm going to take a size of 2 rows and 3 column tensor. Once I do that, I can actually print it out. One thing that I'll be doing in this script is I'll be commenting out the various prints, as well as sometimes even the declaration of the variables to speed up the script. So bear with that, and the same script will be available in the GitHub repo link that will be shared, so you can work on this on your own time. I'm going to execute that modified script where I have the ones, the a1 variable created that calls the ones, and I'm going to print the a1 variable. As the execution continues, we can move on with the next method that we are going to learn. So we are going to learn about the zeros. So here we see the ones has been printed out. So it is a 2 row. So this is a 2 row. There are 2 rows here and 3 columns. So 1, 2, and 3 column filled with ones. Same way, when you are going to do zeros, we are going to say torch dot zeros, and you must have guessed by now this is going to be filled with zeros. So if I do a print on a2, it is going to be filled with zeros. Also, one more thing that you might be observing is that the way I am using the cursor here, I am not using the mouse. That is because I have enabled the Vim based plugin in VS Code, so that all the editing happens in Vim style. That's why you are not seeing it. And I'm going to add one additional method here. I'm going to use size, and also I'm going to print the shape attribute of the tensor. So I'm going to say shape, and then I'm going to finally print the tensor. So I'm going to do 3 prints this time. Okay, and I'm going to execute. So this time, as you are seeing, the methods that are available for each of the tensor is actually a lot. So it's going to take a considerable amount of practice for you guys. So I would suggest that take the script, but you have to start the script separately. Do not use this script and try to run it. That's going to anyway work, but you have to type it. So you have to type each and every letter, and you have to try and execute it. Then only you will find out the errors that you are getting. So here we see that a2.size method as well as a2.shape attribute is giving the same output, that is torch.size type of 2, 3 and 2 column 3 rows, sorry, 2 rows 3 column tensor, and we can see it is filled with zeros. Okay, so we have seen zeros and ones. Let us now move to the next step. So what we are going to do next is we are going to introduce randomness into Pytorch. So for that, we are going to use something called as torch.rand. So torch.rand, and once you are using this torch.rand, you have to give the size. So we can actually mention it as size, or we can directly give the size like this. Once you do that, and once you print it, this will create a tensor with the random numbers or floats assigned inside the various locations. So let me print it, and let us execute this. Let's move forward. And next, what we are going to do is we are going to see something a little similar to rand, but it's called as randn, meaning it will take the values from the normalized set. So torch.randn. So here you see the random number that has come out, and randn. So that is one more option, one more method called as randn, and we can execute that also. Print a4. Print a4. We are going to execute this, and you will see that the distribution of the random numbers are going to be from the normal distribution. How will you know that it is from a normal distribution? For that, we will actually dive deeper into the various supporting methods that we are going to learn a little bit later in the video. So stay tuned for that. So you will see that there are minus values and there are plus values here. On the contrary, the earlier rand option was not having any minus values. So this is something that you guys have to take a look. And the mean, so if I try to get the mean of this particular tensor for A4 tensor, let me do that. Print A4 dot mean. As you can see here, I can directly call mean method on the tensor itself. Method mean is part of the tensor, so you don't need to worry about that. Let me execute the script. Sometimes what happens is we intuitively think, and I am right now thinking there might be an error, because sometimes the methods like mean, median, mode, the various statistics may not be directly available in the instances of the torch tensor. You might have to call, in this case the mean has been part of the instance also. In certain methods you might have to call it directly on torch. So I will explain to you a little later. So you can see that we can do mean, median, and also sum here. You can do the sum, you can do the mode also, and you can get the necessary details, statistics from the tensor. All these things we are doing it in the script only. It's very similar to Jupyter Notebook. Only thing is that we are doing an additional work of commenting out certain print statements. The advantage of this is that you will have a clear idea of where the variables are getting created and where we have to comment out the variables and remove it from our execution flow. So these things you will keep track. In case of Jupyter Notebook, what happens is after a couple of cells you will lose track of the earlier cells. So that is something, one of the challenges that I faced. So that's why I'm moving to script. Another benefit of using script is that finally you are anyway going to move all the code to script, code to a Python script, or going to use a module or make it as a module and import it somewhere else. So at those times using a script is very, very helpful. That is the second benefit. Let's continue further. Next what we are going to do is let us refer to the list that we have. So let us go back. So we have seen the ones, zeros, rand and random. Now we will look at I, linspace and randint. After that we will go to view. So let us go with A5, and I is basically a short form for identity matrix. Basically it's an identity tensor that will be provided with ones in the diagonal. So if I say I, and if I say 4, what will happen is it will give a 4x4 identity matrix with ones in the middle. You can actually update the diagonal also, but it will not be any more identity because it has to be 1, right? In order to update the diagonal, all you need to do is you have to multiply that the tensor with the value that you want. So for an example, if you want to multiply it with the value 5, that is 5.0, then it will get become matrix with 5 in the diagonal. So let us execute this. These kinds of manipulation of the matrices and the tensors becomes very common as we start moving into the neural network training as well as evaluation. At those times you will have to understand how the data is getting modified in a very clear way in your mind. So like when you are going to type this particular command like A5 multiplied by 5 dot, you should be able to visualize what is the output is going to be. So this comes with lots of practice, which I did not know in the past. So the more you practice, the more you see the operations in action, the better you will get at this visualization. So that's also one of the reason why we are doing this step by step. Okay, now next what we are going to do is we are going to use something called as we are going to work on linspace. So we will do torch.linspace. Since here the prompt that we are getting, that is the auto completion that is happening in case of Raspberry Pi VScode, is very slow. The reason being the RAM is not sufficient. So if you go back to the RAM, if you look at the RAM, you will see that almost 300 MB of RAM is already getting used. That is because the VScode server is taking it up. And you will see that the temperature is pretty stable. We are not doing any operations right now. But as we go forward in this series of videos, you will actually come across certain parts where you'll be training, and you will see that this particular temperature starting to go up, and the over temperature signal arises in Raspberry Pi after 80 degrees Celsius. Keep that in mind. Let's go back to the VS Code. Now, in case of linspace, we have to provide the start as well as the end. First thing, so we have to provide the start. I'm going to start at 0 and I'm going to end at 15, and I'm going to have I am going to have the number of steps. So we have to provide the number of steps. If you are going to say 5 steps, this 0 to 15 interval will be divided into 5 steps and the output will be provided to you. So if I say 25, this 0 to 15 will be divided into 25 steps and it will be provided to you as output. So let us see the data. So print A6, and I'm going to execute this. As you are seeing this execution, you are seeing how the output is changing, because every print statement that I have given till now, I am commenting it out. So the print of the last statement or the last variable is only getting displayed to us. You can see that here. So we are actually getting the entire interval 0 to 15 converted to a small numbers divided by 25. So if you want to check whether it is 25, you can do a check on the shape. Okay, before we do in parallel to checking the shape, I am going to now start adding a couple of more operations in each run. So till now I have been running for each and every method, right? But that's not required. You can actually do multiple methods. I mean, you can type in multiple methods and then you can run multiple methods and look at the output as a batch. So that is also something that you can do. I'm going to run torch.randint, and in case of random int, I am going to provide the random int has to be between 10 and 20, and the size is going to be between the size of the matrix is going to be 2 cross 3, size of the tensor, sorry. Here we are seeing that the interval between which we want to collect the numbers, that is 10 and 20, and we want the matrix to be 2, 3. And once we execute the print statement on these elements, we are going to see the output right now. So let us execute that, and you will see that we will look at the shape of A6 also. We will get 25 as the shape. The shape output is also matters a lot. So I will explain that once this output gets printed out. That is a one-dimensional matrix. So this is actually a single-dimensional tensor. This is a multiple-dimension tensor. Like this has 2 rows and 3 columns, and we see the size is coming as a array of 2, 3, array of 2 elements. But this particular linspace, that is linear space, is coming as a single dimension. There is no any column, and this is this you cannot even call it as a row. This is very similar to an array. That's all. There is no multiple dimensions here, right? Why this is very important is when you are going to work on this kind of tensors with the model layers that you will be learning down the line, there you need to see what kind of data that you are going to push into the model. If the data is of wrong shape, then your model will not be able to operate on it, and it will throw the error. So we'll be seeing a couple of errors also, and we will learn from that too. So we will continue doing this. Let me go forward and we have seen the linspace, we have seen the random int, and what we are going to do next is we are going to start modifying the tensors by using a method called as view. So let's start. Let us take a6 and I'm going to name it as a6a. You will see why in a couple of minutes, because I'm going to play with this 25 elements, and I'm going to see how I can modify them. So I'm going to stop printing this. We don't need this anymore. We will work with the random later. We are going to start by printing a6. So we'll print a6, and at the bottom, in case of a6a, what we are going to do is we are going to use a method called as a6 view. So a6 view, and in the view takes two arguments. So it takes the column that it takes the row that you want, and it also takes the column that you want. We know there are 25 elements in a6, so I'm going to say I want 5 columns and I want 5 rows, and I'm going to print a6a, and it will work. So you will see that it doesn't have any issues in executing this. And once you do that, you will see that the array that we got in a6 would have been converted to a two-dimensional tensor in a6a, and we can also print the shape to see how it changes. Okay, you have seen that here, right? So this is having only single dimension. You can see there is only single square bracket, but in case of the same values are getting repeated. Can you see this here? The same values up to 2.5, that is 5 columns, are available in this single row, and then the next 5, so this next 5 is available in this row, and same way. So view function has basically broken down a single list of tensors and converted into a two-dimensional tensor. So this is what we saw, but that's not where the power of view is. What will happen is, if I actually remove this -5 and if I give -1 here, view function is smart enough to know, okay, if I have to create 5 columns, then based on the number of elements, I have to create 5 rows. So it will know to do that. We can execute this right now, and you'll see the same result comes out. And also you'll see that the shape also comes out. We will see the shape right now. So it will be 5,5 size. So you will see that output. Just give it a second, and we will continue to the next step. So we saw that even if you give -1, the reshaping happens, and we see the output as 5,5, 5 columns and 5 rows. So in this video, we have covered a lot of ground. We have seen the basic functions that we need to understand, basic commands that we need to understand in case of Raspberry Pi. We understood the reason why we are trying to learn the Pytorch methods, and also we saw the overview of various Pytorch modules and the possible classes and methods under each modules. Not all the possible methods and classes, but a couple of classes and methods that we frequently use. So in the next video, we will continue the torch module methods, and we will try to understand more about these methods that we have not covered yet, these methods, and then we will also cover these data manipulation methods also in the next video. So till the next video, I would suggest that you guys understand how these commands work, and also try to get familiarized with how the VScode and how the remotes in VScode works, so that you can do the similar kind of scripting and you can execute it and see. So with that said, I would like to leave this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.